So when we do this, if you look at the top of the handout that I just gave you, I have it broke down into steps, what we're going to do as we work through these. The first thing we always will do is factor the top and bottom of our fraction. The reason we need to do that is because of this instance. This is the one thing excuse me, that is not on your notes handout. It's a hole in the graph. So we talked a little bit about this yesterday when we looked at domains. When you factor and something cancels out, that creates a hole in the graph. So x squared minus 9. That breaks into x plus 3, x minus 3 over x plus 3. You guys see the x plus 3 cancels here and you're just left with x minus 3. But like I talked about yesterday, the graphs of these two things are not identical because of the domain. The original one, what's the domain? What can x not be in the starting one? -3. And in the final one, x could be anything. So what happens when something cancels? That puts a hole in the graph. To find that value, what makes x plus 3 equal 0? -3. To find the y value, you plug the -3 into what's left. So after I cancel, if I put my -3 in here, we get -3 minus 3, which is -6. So when we graph this, x minus 3, that's just a line, y-intercept of -3, slope of 1, but it has a hole, an open circle, at -3, -6.
How did you get the x value?
The thing that canceled out, you set it equal to 0. So we have to factor first to see if we're going to have any holes in our graph. Okay, and if you do, you have to find the entire ordered pair, so you can put an open circle there. If nothing cancels, then we move on to the next step. So we said factor it, reduce, and then the next thing I told you to do is find your intercepts. X-intercept is just when y equals 0, y-intercept is when x equals 0. Then we will find all of our asymptotes, and then we'll plot everything and draw the final graph. So here is our first example. First step, factor and reduce if we can. So x minus 1, I can't do anything with it. X squared minus 4, we can factor difference of squares, that's x plus 2, x minus 2. Nothing cancels, so there is no hole in my graph here. So the next thing we have to do is the intercepts. Now let me ask you a question. To find an x-intercept, what do we do? Plug 0 in for y. Okay, so if I set this whole fraction equal to 0, what would you do to get rid of the fraction? Multiply the denominator. And what's 0 times the denominator? So when a fraction equals 0, if y is 0, that really just means the top of this fraction equals 0. So you can either just work the whole thing out, or x-intercept is just going to be what makes the top equal 0. And that would be 1. So you can plot that on your graph. We hit the x-axis at positive 1. Y-intercept. How do we find a y-intercept? You can do it in the original or the factored. It doesn't matter a bit. Which one do you want me to put it in? The factored. Okay. So 0 minus 1 is negative 1 over 2 times negative 2, that would be negative 4. So we get a positive 1/4. So we hit the y-axis at 1/4. Vertical asymptote is x equals, because it's a vertical line, and it's just whatever makes the bottom 0. So what makes the bottom 0? X equals negative 2 and x equals positive 2. That's one of the benefits of having it factored. Then you can just look at your parentheses. So we draw those in as dashed lines. Negative 2 or positive 2. Then we decide if it's horizontal or oblique. We talked about yesterday, you can't have both. It'll be either or possibly none of them. What's the degree of the top? And the bottom? If the degree on top is smaller, it is horizontal, y equals 0. Okay, it looks a little bit concerning because you have a point on that asymptote, but remember yesterday I told you it's possible to cross a horizontal asymptote in the middle. The ends won't touch it, but the middle might, so that's not a big deal. Then, what we're going to do to get our graph is just use our graphing calculator. If you're at home and you don't have a graphing calculator, you can use Desmos on your Chromebook to just get an idea of the graph. We have all the exact stuff we need plotted already. So when you go to graph these, put in the original just to try to help you catch any mistakes that you might have along the way. You need to include parentheses around both the top and the bottom. So we have x minus 1 over x squared minus 4. So I can see my graph. Starts out going down. We've got that little piece. So we have to draw this in. The asymptotes are points or are lines that you are approaching. If you draw a graph and it looks like this, am I going to accept that? No. So many problems with that. First of all, it wouldn't even pass the vertical line test. It's not a function. Second of all, it needs to be approaching your asymptotes. So I'm not making you do any more exact points, but you need to make sure that as time goes on, you have a nice smooth curve approaching all of these. So the middle kind of looks like this. The only place you can hit the x and y axis are those dots that you've already put. And our other end was up here above the horizontal asymptote. So this graph will help you identify if you have any mistakes along the way. You know, if the graph that you're getting on your calculator doesn't fit the information that you've plotted, then you need to take a step back and figure out where your mistake is. Other questions there? So that's all we're doing. We're just going to keep practicing these. Let's go ahead and look at this one. So first step, factor. What can we do to factor this? Difference of squares, x plus 1, x minus 1 on top. Okay, intercepts. X-intercepts, I told you the shortcut is just to look where? The top. What makes the top 0? So we hit the x-axis twice. Y-intercept. To find that, you plug 0 in for x. You can do the original, you can do the factored form. Can you divide by 0? So that means there is none. This one will never hit the y-intercept, never hit the y-axis, because we get 0 on the bottom. Vertical asymptote. X equals whatever makes the bottom 0. Now we have to decide horizontal or oblique. So to do that, we look at the degree. The original, the degree on top is 2, the bottom is 1. Remember, if the degree on top is smaller, it's horizontal, y equals 0. Same degree, it's horizontal, you divide leading coefficients. The one case where we get oblique is when the top degree is 1 bigger. So this is oblique. How do we find an oblique? You have to do long division. We're looking for y equals mx plus b. So the x squared minus 1 goes on the inside. If you want, you could put a 0x there as a placeholder. And our x goes on the outside. So then you divide. What's x squared divided by x? Then you multiply. X times x is x squared. Subtract and those cancel. My next term is 0x. What's 0x divided by x? Just zeros. Do you even have to include the plus 0? No. So our oblique asymptote is just y equals x. So that is a line. Y-intercept is 0, slope of 1, so up 1 over 1. And then you use your graphing calculator to help you fill in the gaps. So you need parenthesis x squared minus 1 over x. Make sure when you're drawing this it is curved. You do have to go through your x and y intercepts. And you're just approaching your asymptotes. So it looks something like that. Okay. So far, so good? Let's do the next one. So first step is to factor everything, but I've already done that for you. Then we reduce, but nothing cancels out, so we can jump right into our intercepts. X-intercept, that's when y equals 0, which in a fraction is really just when the top is 0, so that would be -1. Y-intercept, you plug 0 in for all of your x's, and you get 1 over 0, which means none. Vertical asymptote, x equals, what makes the bottom 0? X equals 0, that's just the y-axis. And x equals -4. Horizontal or oblique. When you have the degree, when our terms are just added and subtracted, like the previous examples, we just looked at the highest or lowest power. If it's in factored form, you have to think about, if I multiplied this out, what would be my highest power? So on the top, we just have an x, so that's degree 1. On the bottom, if you distributed, you would get an x squared, so degree 2. So what kind of asymptote do we have? Horizontal, and it would be y equals 0, because the degree on top is smaller. Okay, warning, when you go to graph this, make sure you need parentheses around the entire numerator and the entire denominator. So this first piece, we can see it's below your horizontal asymptote. What's the middle piece doing? Bless you. What's going on here between my two vertical asymptotes? Yeah, it's kind of like just coming down. Your x-axis, and if we zoomed in a little bit, it'd be a little bit easier to see. It's just coming down there. And then the last part is, again, above horizontal asymptote. I'm not making you get any other exact points. What I'm looking for is your intercepts, your asymptotes, and the shape of your graph. Okay. How are we feeling about this in general? So? Are we okay if I maybe skip around and don't necessarily do all the examples? I'd like to maybe do one more for sure, and if we need more than one, we can do that. I want to skip the next example. I'm going to go to this one. So how would I factor the top? Good. So I need two numbers that multiply to 4, add to -5. What would that be?
-4, -1.
Good. So then we can factor. So we get 2x minus 1 and x minus 2. What about x squared minus 4? Then what's going to happen? Those x minus 2's cancel, which means there is a hole in the graph. So to find that hole, the x value is from what canceled. What would make x minus 2 equal 0? To get the y, you plug 2 into what remains. So if I plug a 2 into that, we get 4 minus 1, so 3 over 4. So at positive 2, 3/4, there is a hole, just an open circle in my graph. Now I'm just using this yellow highlighted part in my final reduced form for the rest of my information. So X-intercept is really just what makes the top 0, so that would be 1/10. If you ever can't tell, you could just work that out, say 2x minus 1 equals 0 and solve it. Y-intercept, if we plug 0 in for all of our x's, we get -1 over 2. Vertical asymptote, x equals, what makes the bottom 0? -2. Okay, now we decide horizontal or oblique. When you're looking at your degree, it's not going to matter if you look at the original or your reduced. Either way, we're fine. If I look at the original, the degree of the top was 2 and the bottom was 2. You know, if we looked at our final one, it's 1 over 1. Either way, it's the same degree, which means what kind of asymptote? Horizontal. To find it, you divide the leading coefficients. So think of it as like 2x squared over x squared, or 2x over x. You get y equals 2. So then, we'll graph this. I prefer to graph my original, just helps me catch any mistakes if I may have made them along the way. So I can see it starts out above my horizontal asymptote, and then the second piece is kind of curving. Make sure you don't accidentally fill in your open circle when you draw that. So it should look like this. I've done all the different variations. I've done an example of each type of asymptote, one with a hole in the graph. Do we need more?